Hey guys, and welcome to Top Channel 101, and today we're going to be looking at how to make this twisting rope animation in Blender. So yeah, we have a bunch of ropes and we have this rotating. So yeah, let's jump in. By the way, this is also being recorded in 2K, so if you want to get a more detailed version of this, there's a 2K version that you can watch. And the project files are going to be in the description on my Gumroad page and my Patreon page, and also on my YouTube members page. So if you're a YouTube member, make sure to check the YouTube community tab. Should be a download link to these files. So let's jump in and look at this. Okay, so we're going to need a plane. I'm going to rotate it 90 degrees on the Y, like that, 90 degrees on the Y, like that, and then move it to the other side, like that. I'm going to subdivide it a few times and then extrude it like so. So you want to subdivide it to the number of ropes you want. So I'm just going to extrude this, and now we have something like that. And I can go into edit mode and just select all the faces, the middle faces, and hit X, then delete only faces, so that we are remaining with just these edges and the faces at the end of these ropes. We can select these edges, subdivide them, and give them more resolution. So we're going to use a resolution of 20 or 20 cuts. This might not be enough, so I'm just going to select this face, and that face. Shift G area, that will select all the faces, and then I can go to edge mode, Control I to select the inverse, and then subdivide again so that I have more point. Now what I'm going to do is go to the physics tab and create a cloth simulation. If I hit play, everything just falls. We want to invert the selection. Actually, invert the selection. Select the faces on the other side, these faces. Give them a new vertex group, assign, and use that vertex group as the pinning group in our shape settings for our cloth. So pin, hit play, everything falls. Now let's start twisting this. So to twist this, we want these faces. I'm going to use Shift G area to select. Actually, I only want this side. Control H to hook these faces to an empty, and I can rotate this empty. Set some keyframes and rotate this like this. So if I play back, we get those rotating like that. Now I can also do the same thing on the other side. So I'll go to face mode, select face mode, select those side, Control H, hook, and then I can rotate these. I can keyframe these to rotate on the opposite side. Rotate X, perfect. So now if we play back, these are they're all rotating in opposite sides, but they don't seem to be affecting the cloth. And the reason for that is that if we select this mesh and go to the modifiers, you can see the hooks are after the cloth, so they're not being added to the simulation. So we need to move this cloth below the hooks so that the hooks are also part of the simulation. And now if I rotate, you can see we get the twisting, but you see that because these lines or ropes don't have any thickness to them, so they're just going through each other and not really giving us that interlocking. Yeah, that's a rope effect where they're kind of twisting together like that. So first thing we need to do is make sure we have self collision. So I'm going to go and I think it's under collision. Yeah, self collision, turn that on. Again, if I play back, we're still not getting any cloth collision because these are just vertices, and collisions are supported for faces. To make sure that we have collision for these edges, all I'm going to do is just select these faces, and these faces, go to edge mode, and then Control I, insert. I have these edges selected. What I'm going to do is extrude them on the X just a bit, like that, so that these are no longer just edges but actual faces with some thickness. Now if I play back, because now these are faces, they should be supported in the collision. One thing you will notice is that our pin groups are now messed up. So what I'm going to do is just come back here, go to the vertex group, select the vertex group, and just grow the selection a bit, assign vertex groups, and I'm going to select these here, just push them back a bit, select this, push them back a bit, Again, make sure we have this as part of our vertex group, and also make sure that they are also hooked up to the hook. Right now you see they are not really hooked up, that's why you see that we're getting that effect there. So let's go back here and just make sure that you have those selected. You have only one side selected like this, and this empty here is called empty. Yeah, it's called just empty. So we can go to the settings here and make sure that these here, if we use Ctrl H, are also assigned to hook empty, and the empties, the vertices here, this side, Ctrl H, are hooked up to empty 001, which is this here, as you can see from the top here. And now with that, we can, let me first see if I can make this easier to see, playback, and I see we're now getting a proper twist, and the vertices are starting to collide with each other. The only issue we are having right now is that we don't have, the collision quality is very low to give us something good. So what I'm going to do is increase this a bit to something like 6, and also increase the collision distance, because right now the collision distance is very small. So after adding the thickness, if we don't give it a large enough collision distance, our ropes will start to intersect with each other. So you want the collision distance to be as thick or as large as the thickness of your final rope. So I'm just going to increase this to maybe it's supposed to be self collision distance to maybe 0.02, maybe 0.03, I don't know. So let's try this and see. Yeah, you can see now we are getting proper twisting. The ropes are really tight because of their length. So I'm just going to let them sag a bit by changing the shrink factor, giving it a negative shrink factor so that they can be a bit saggy, and when they start twisting, they give us a nice twist. You can see how they are colliding with each other, and the gaps between these are being determined by the collision distance here. So you can play with that if you want, but I think this is good enough for me. Yeah, so this could be used for some nice hanging wires. The only issue is that how they are rendering. They're just rendering like a slice of a plane, and not a rope as in the final example here. So let's work on that using geometry nodes. So first thing I'm going to do is just bake out this simulation, because I don't want it to change while I'm working in geometry nodes. So I'm going to go under Cache and just decide how long I want this. So for 250 frames is enough. I'm just going to bake all, bake, perfect. Now we just have to preview this one more time. Let me turn off these overlays and see. Yeah, you can see how this looks. I think it's satisfying. Now let's go to geometry nodes and see how we can set this up to make it look like a rope. So I'm going to switch to geometry nodes here, create a new setup, and let me zoom in here. Okay, this is what we have. The first thing we're going to do is just remove these faces here so that we only have the ropes. So to do that, I'm just going to use a separate geometry, grab it here. And what I'm going to do is just use the face area. If I bring back my overlay, I'm going to use the face area to just delete faces that have an area above a certain threshold. So you can see these faces are larger than any of the faces here. Okay, so we're going to use the face area to determine what faces we want to select. Just going to use the face area and use a compare node and just compare the areas. So to our value here, so connect this here. So any faces with an area greater than this should be removed. So that leaves us with these faces. Now with that, we have two parts. We have the faces, and we also have these lines here. So now we need to convert these into curves, actual curves, so that we can be able to give the curve some thickness. And to do that, what we're going to do is delete these middle lines here. And to do that, if you look at these, you can see that if you look at this edge here, it is connected to this face and to this face, while these outer edges are only connected to one face at a time. And we can use that to our advantage. There is a node called edge neighbors, and what that does is it gives you the number of faces each edge is connected to. So this edge here is connected to two faces, like I said, and these other ones are connected to only one face. So we can use that to delete geometry or delete any edges that have a face count of greater than, of greater than 1, and that will remove those edges. So, but we still have these ones here at the end, and if we look at the end of this, we also still have these ones here. We also need to remove those so that we can delete this edge here. So to do that, if I disable this, and the reason why we still have those is that you can see that though these are connected to two faces, this one here, the end corners, the end edges are connected to just one. That's why they're not removed. To remove them, we're going to use a proximity node, geometry proximity, and the target are these faces here. So any edges that so let me get these. Any edges that are closer to these faces should be removed. Proximity, geometry proximity, bring in these faces here, and we can use another delete faces. And we want to delete by distance this time. We can use a compare node. We want to, let's see, we want to use less than. Yeah, so we can delete any edges that are close to this, and you can see that will remove those. Now we remain with two edges. We can convert this now to a curve if we wanted to, but the issue we have now is that we have, for each rope, we have two edges. So if we tried to add thickness by using a curve to mesh, a mesh to curve, and then curve to mesh, and then a circle, you see that we will have two ropes per, we just have two ropes per rope, which is not what we want. So I'm just going to disable this for a second so we can go back here and look at this more carefully. Now, to remove the extra edge, what we can do is use edge islands. Since these are still meshes, each path or each curve we're seeing here is a mesh island. So we can use mesh islands. And what this will give us is an index for every edge path we have. And if we use a delete geometry, and we want edge, and I use the index of the island as the selection, and maybe we can use a compare node here. Just increase this. You can see we have the ability to just remove more or reduce more. And if we move closer, you can see that the advantage we're having is that we are counting up each island. So the first rope island has an index of 1, and this one has an index of 2. If we go above, we get 3, and then 4, and then we go to another rope, 5, 6, 7, 8, 9, 10. We're counting out each rope, 1, 2, 1, 3, and we can use that to our advantage. Since we know that the second edge is always going to be an even number, we can use that to our advantage and use a math node and create a selection of all odd numbers by using the modulus, and that's why you can see that now each vertex or each path or each rope is just one edge as we wanted. Now we can do the other conversion to curve and then to mesh, and now you can see that our ropes are just exactly as we expect them. Now the resolution is not enough, so what I can do is before we convert back to a mesh, I can do a subdivision surface to make things much smoother, like that. So playback, and we can control the radius of the ropes by just increasing this. And remember, this radius here should be around the radius of your self collision, or otherwise things are going to be intersecting. Actually, I can even delete the back here and just play back. And I'm also going to reduce the resolution so that I have a smoother playback here. Now I'm going to set the collision distance to 0.03 so that I can set the radius to 0.3 as well, and that should make sure that we don't have any any overlap, any intersecting issues, and yeah, I think that is great. So now let's work on materials. For the materials, I'm going to use a set material here, set material node, and I'm going to create a new material, call it rope, and I use it here. And I'm going to go to the materials, to the shader editor here. Let me go back to geometry nodes. Make sure that you output this as the final node, as the final geometry in the group output. I can even remove the viewer for now. Can come back here to the shader editor, select everything. Now we can start working on the material. So the first thing we need, I'm going to use my texture folder to import in some rope textures. So I'll search for rope. By the way, if you want to support me, you can get texture folders. Links are in the description. I'm going to just get any of these. Let me use, I don't know, this, that in. Perfect. Okay, it works, but because we don't have any UVs for this rope, that's why you see that we don't really see the texture. So what I'm going to do is set up a few UVs, and I'm going to do that by first creating an attribute node, name it UVs in the UV editor, in the shader editor. Preview that. See, we're seeing black because we haven't created this attribute in geometry node. So let's go to geometry nodes and let's see how to set up some UVs. So I'm going to come here and use a capture attribute, because I want to capture the length of these curves and use that as our UV coordinates. And I'm also going to do this for the circle here. Now, let me use a spline parameter. That should give us the lengths. I can duplicate this as well. And from here, I can add a store named attribute. Create the attribute that we use in the shader editor. Make sure you name it the same as in the shader editor, called the UVs. Now, if I play with the value here, you can see it changes because it's updating there and also updating in the shader editor here. So let me go back to the geometry nodes. Now, because we are creating UVs is a vector value. So let me change this to vector. Now, what I want to do is use a combine XY. Use the factor from the first splines as the X value. That should give us the X value, like you said. And then the factor for all the lengths for this here should be the Y value. And now we have our UVs. If you go back here to the shader editor, I can now use this as the rope. Because of the length of our rope, we might also want to multiply the factor by the length. So I'm going to just add a math node, multiply this. So if I multiply this, you can see that I'm scaling down or I'm scaling up the rope until we start to see it correctly. I think let me change to a better rope texture here. Let me use this switch. Yeah, so something like that. If I go back to the editor here, yeah, we just want to multiply the factor by the length, and that should give us better tiling for our UVs. The other thing, we can go back to the shader editor. Now, if you're not satisfied, you can add mapping nodes, and I just scale that however you want. Okay, I think we might also want to rotate these around maybe 90 degrees so that the UVs are rotated correctly. We might also want to do the same thing for this, just multiply the length with the factor to get the Y coordinates. Can go back to the shader editor. I think I'm liking that. I can connect this to the base color, and I have a rope, add some vector bump detail like that. The other thing I did for the original version, I added in some random colors. And to do that, all you need to do is just store a named attribute for the different islands. So I'm just going to store a named attribute around here and just set this to random. I can go to the shader editor just to preview that while I'm working on it. So just duplicate this attribute node and preview that. See, we're getting nothing because we haven't input anything into this random value. And to do that, we're going to use a random value, connect that to the vertex, to the value, and you see we get random values, but they are per vertex. We want to get per island, so I'm going to get the mesh island and use the island index as the ID, and that should give us a random value for each island, like that. Now I can go back to the shader editor and just use a ramp, a color ramp, set the different colors that I want. Let me change this to constant. Wires red or pink, some green, and I can just connect this to be the base, and we have some wires. Again, everything still works perfect. There is that random jitter that we are getting, and I think it's because of how we are setting up this random value here. I think we should, let's see, do that instead of putting it here, because it changes a lot. We need to go back after we delete, we separate, I think, the geometry. You would have to make sure that we don't have that jittery effect. We can do that before we delete, I think, around here. So if I do, I just have to remove this and just do this here. Let me make sure that I'm looking at the right thing. We need to do it here. So I'll need to store a named attribute and connect this here. And yeah, that should remove the jitter effect. So you can see we don't get that anymore, and everything seemed to work just as expected, and things look stable. The last thing I did was just set up some. I think I didn't stabilize the color, the random colors. That's why you see we have, I don't know. Yeah. You can see that the colors are changing randomly in some areas, because I didn't fix it in the same way that I've done here. By just moving the random color, you see the colors are not jumping around anymore, so they're stable, which is great. Yeah. Anyway, if you want to check out the project files, all links are going to be in the description. By the way, if you're looking for some procedure materials, Sanctus library is a library of procedure materials. A lot of procedure materials that you could use for your projects. And yeah, if you use the affiliate links in the description, they really help out the channel. And you also get something out of that. So you get this amazing product here. Has a great customer rating. So you know you're getting something very, very useful. I'm going to leave all the links in the description. Thank you.